Hello everyone. So today we'll be solving a harder problem. Minimum number of taps to open to water a garden. So what we are given is a one-dimensional garden on the x-axis, and the garden will be starting at the point 0 and will end at the point n. That means the length of the garden is n. Now there are n plus 1 taps means located at each point from 0, 1 till n in the garden, and each tap has a given range, means we are given a ranges array of length n plus 1, which will denote the means the range of each tap with which within which range we can water in the garden. So we are given these ranges, and we need to like return the minimum number of taps that we need to open such that we are able to means water the entire garden. And if it is not possible, then we simply need to return -1. So for example, if we had the range as this, means from 0 till 5, okay, and we have these 5 tabs, means 6 tabs available with the range as this. So for the first tab, the range will be from, since it is present at index 0, so it will be from 0 minus 3 to 0 plus 3, means from -3 till +3. Okay, next for this is index 1, so it will be from 1 minus 4 till 1 plus 4, so it will be from -3 till 5. Okay, then for this one it is at index 2, so it will be 2 minus 1 means 1 till 2 plus 1 means 3, so it will be from 1 till 3. Similarly, this will be from 2 till 4. Now this has a range 0, so this means it is from 4 minus 0 till 4 plus 0. So this means this will not be able to water any specific range. It will only be able to water a specific point. So means this will only be able to water this point. And obviously like this will never be useful. Okay, because we are not able to means water any range using these values. So these are like, we can say like not useful at all, because we need to cover the entire range with water. Right? We need to cover these ranges with water, not just the points. So if one tap was able to like means satisfy this range, that means it would have covered the range points 0 as well as point 1. So if a means tap exists at this position with such that it means only waters this position, then it is not means doing any good. So this is like not useful at all. So one thing like we observe, like the values which means the ranges which is like I to I means x to x, this is not useful because they will not be watering any range. Now once we have made the observation, so for this given input we need to cover this entire range and using the minimum number of taps required. So we'll means use the ranges such that we need to utilize the minimum number of ranges to cover this entire range. So you'll see like if we pick up this tab, means the second tab that we had, which had the range from -3 till 5, we'll be able to cover this entire range from 0 to 5, right? And we are able to cover this entire range, then that means this single tab will be able to satisfy this, and hence using only one, means opening only one tab, will be able to water the entire garden. Hence the output here is 1. Let's see another input. So here it is 0 0. So we have the tabs. Suppose the array location is like this, and we have 0 1 2 3. Okay, so n equals to 3. Now for at 0 we have a tab which has the range covered by this only. Okay, for 1 this, for 2 this, and for 3 this. So we can see we'll never be able to like means spread water in this range, right? Because we need to spread water such that it covers the entire garden, means it should cover this area. But these points, means these waters are only covering the specific points, not any range. Hence we will not be able to means garden means water the entire garden, and hence the output here is -1. So I hope like you are not, means when you read the question you did not thought like you need to cover all the points. Even if you cover all the points, that does not mean that this entire ranges are covered. Means even here we are able to cover the points 0 1 2 and 3, but we are not able to cover the region lying between those points, right? So I hope one means confusion is clear here about the problem statement that we have. Okay, so now how do we like approach this problem? So what do we need to do? We have like means we have L to R intervals for like each tab, right? So what if we'll first like find out these L to R intervals. So suppose we find out all the intervals. So we have L1 to R1, then L2 to R2, and so on till from L0 to R0 till Ln to Rn. Now what do we need to do? We need to pick some intervals, pick some intervals such that we are able to cover all the means ranges from 0 to n, means we are able to cover from 0 to 1, then 1 to 2, and then so on from L minus 1 to n. Not only just the points, we should be able to cover these ranges as well. Okay, so this is the requirement here. Now you might have already done a question, means this like seems pretty simple because we already have a problem. Like if we are given n intervals and we need to cover all the points from 0 till n minus 1, then we'll simply, what we're doing, we'll be just simply sorting the intervals and then means optimizing, updating the rightmost in such a way that at each step we are updating it in the efficient way. Okay, so this is what means the approach that we'll follow for if we were required just to cover the points. So let's try to like extend, maybe if we try to extend this approach to solve this problem, we will be able to solve it. So the first step is to like, if we have already find out all the ranges of each tab, let's try to first sort it. So that means first we get all the intervals which are means having the left point at 0, so that we pick the one which has the maximum right, means it, suppose it covers from 0 to 1, it covers from 0 to 2, it covers from 0 to 5. So we'll obviously be picking the tab which covers as much range as possible for 0. Okay, now what will be the next step? Suppose we have picked 0 for, means 0 to 5 is now covered. So what will be the next tab that we will be covering? We will pick up a tab such that its starting point is less than equals to 5 and it covers the maximum range. Okay, so even if suppose this tab was lying earlier and it covered this range, and this tab, new tab, had a range of this line, this only. So we'll obviously be picking this tab only, right? Because this is covering the farthest most right point, right? So in a greedy step, what we will follow for each range, suppose we are able to cover, means the current end that we have is 5. So what we'll do, we'll find out some tab which is less than equals to current end and which covers the means the farthest right. Okay, farthest right means a range which starts at some point less than equals to current end, but it covers all the portion till right. And current end equals to 5 means we are able to means fulfill the region of 4 to 5. Okay, so what will be means the starting point of current end? It will be, since we have 0, 1, 2 till n, so initially the current end should be at 0. That means we have watered till here and now we need to water these portions. So initially current end should be 0. So this means we have, means the boundary of water that we have till now is at 0. Okay, is just before 0. Okay, till this point. Now we need to cover from starting from 0 till n. Okay, and at each step what we will do, we'll have the ranges. Suppose we have the current interval as L to R. So what we'll do, we need to find out such interval which is like L is less than equals to current end, and this R that we get for multiple L, suppose it was L1 R1, L2 R2, so there will be multiple L's which satisfy this condition. So Li is less than equals to current end, so we need to find out the Ri which is the maximum, right? That Ri will means that range will be picking, and then update our current end with this Ri. So now what will be the scenarios where like this means watering will not be possible? So if at any point we reached a position such that the farthest means, if at any point we reach a position such that our I is the same as the current end, means, or suppose it means like the farthest that we can get is remains same, means this Ri max that we will be getting it remains the same as the current n only, then that means we'll not be able to like what are the range for further values, because the next range will start from I plus 1 only. So we'll not be able to fulfill this water region for I till I plus 1. Okay, because we are going in a sorted interval order. So if the current L means the next L will start from I plus 1, so we'll not be able to fulfill this watering region. Okay, so I hope you are able to follow the approach that we will following. We will simply apply a greedy approach to pick the intervals, so that at each step we are picking the interval which is means satisfy the condition for covering as much right portion as possible. And hence for this, to cover the range in means intervals in this fashion, we'll obviously need to sort the intervals on the basis of the start point. So we just simply sort intervals on the basis of start point, and then we'll do this approach of finding out the maximum at each step. And when we are utilizing this maximum means this farthest that we get is greater than current n, that means we need to utilize a tab, so we'll increase our tabs count by 1. Okay, so we'll keep doing this at each step where this RA maximum that we are getting is greater than the current n. Okay, so I hope the logic is clear. And as you can see, like sorting will obviously take, we have n points, so sorting them will take n log n, and this loop that we'll be doing it till this current n is like we have not been able to satisfy this till n. Okay, so this current n is less than n. Okay, so we'll be doing this till n, and till it is less than n, and at each step we'll find this L means find this L such that it is less than current n, and we'll find the farthest point on the right. And after we have find out the farthest end, we'll check if it is not possible, then we simply return -1, or else we'll be increasing the tabs count. So this is the approach, means the greedy approach that we'll follow. It is like it has been means it is a sub means the smaller problem of covering all points from 0 to n-1 can be considered as a subset of the problem that we are currently solving, because here we just need to cover the points, now we need to cover the ranges as well. Okay, so we need to do extra checks here. So I hope the overall logic remains the same. This will be a medium problem, and since we need to do extra checks here, this makes us a transition from this medium problem to a hard problem. Okay, so I hope you were able to see why the extra checks are needed, because here we were just checking for the points, and now we need to account the ranges as well. Means tabs at these point will not be able to satisfy the requirements. We need to fulfill these ranges. So this is the main observation that we need to do in this problem. So let's see the code for this approach. So what we'll do, we'll find out the ranges for each the left and right interval for each range from from 0 to n. We find out the left part, we keep a limit so that it does not becomes negative, and we keep a right limit as well so that it does not exceed n, because we simply do not need it. So we'll push the ranges in an array, and then we will be sorting it on the basis of start points, means the left points. Okay, now initially the current end will be pointing at 0. That means we have covered water till this point, just before 0. Now we need to cover till 0 to n. Okay, so we'll move this current n till it is less than n, means we have not yet reached n, because obviously there will be some tab present at nth, and in the worst case it will be covering that nth point itself. So we need to move this current n such that we are able to cover just before this n. Okay, now because it will always be possible that at the nth tab we'll be able to cover the nth point. Okay, so what we'll do, we find out the farthest that we'll be able to get, such that this L means current n if we have. So we find out the farthest that we can get such that the L of the intervals that we'll be having is less than that current n, means it is less than that current n. So we'll move this I till we have the L, means it is the L is less than equals to current n, and update our farthest with the R. Okay, so we find out the farthest R that we'll be getting, so that we optimally pick the tab which covers the widest range. Okay, and we'll simply update. Now if we encounter a condition such that the farthest that we can get is the current end only, then that means the next L will be greater than current N, and hence will be not be able to cover the range from L till current, the new current N will be having. So hence in that case we'll simply need to return -1, or else if it is not true, then we'll update our current end with this farthest value that we have and increase the taps count by 1. So initially if the current end was pointing at 0 and we had a range from 0 till 6 and 0 till 9 and 0 till 4, so obviously this farthest will be storing this 9 value. So hence we'll be using the tap which covers the range from 0 till 9 and ignore all these values. Okay, so and increase our taps count by 1. So I hope this logic is clear now. How we'll be using these means the sorted intervals range to utilize our logic of always picking the interval which lies, means whose starting point lies behind the current end, and it is covering the means maximum portion on the right. So this was the approach, means for this problem using sorting. Now can we like further optimize it, because this is of the order of n log n. Okay, so this will like definitely pass. Here the constraints means n can go up to 1e4. So if you like try to submit this code, this is the same code that we have. So let's try to submit it and see how well it does. As you can see, like it runs in 7ms and beats like 33% of the users. So can we like further optimize it, like because currently it is speaking 33%, that means like maybe better solution still exists. And since it is still means n log n and we are doing this extra sorting thing here, so can we like means only in this big of n can we do it, means can we avoid this sorting thing, avoid sorting. So yes, we'll be now discussing the approach of without sorting, means the big of n approach to solve this problem, big of n time complexity approach. So what is the redundancy, means that we need to observe to transition from sorting to without sorting. So at each step what we are doing here is, at each step we need to find out the maximum right that we are able to get, right? Maximum right that we are able to get. This is the means the benefit of sorting the ranges was having. So what if like we already calculate this maximum R that we'll be able to reach from any starting point? Okay, what if it is already calculated? Then this sorting thing is not needed, right? Because we are already aware of, from the start point, we are already aware of all the ranges that we have. If it start was 0, so of all the ranges of 0, 6, 0, 9 and 0, 4, we know that 9 is the maximum here. So we'll store the maximum reach from this start point 0 as 9. So if we already calculate a value vector of max reach of n plus 1, if which denotes if means max reach of I will denote like if we start at I, what will be the maximum, what will be the, if we start at I, what will be the right, means the maximum point on right we can reach, starting from this I. Okay, so we can like simply pre-compute it, and this pre-computation will like help us avoid the sorting that we needed to do. So we moved on from a constant space kind of thing to big of n, but we were able to reduce the time complexity. Now once we have this max reach vector calculated, we will follow the same approach only. We'll be following the same approach of using current end and finding out the left and the farthest portion at each step. So we'll be following the same approach, just this max reach calculation is required. So I'll be showing you like how this max reach is calculated, so that it gets into your head. So for each point from 0 till n, we need to find what if we start at this particular point, what is the maximum we'll be able to reach. So we move on in this ranges array, we find out the left and right, and the maximum means maximum that we can reach starting at this left will be the right that we'll be having. So we'll update it with max of the max reach that we have already calculated. Suppose it was 0 to 6 and 0 to 9. So initially if this max reach of left was 6, then in next step it will be updated with 0 to 9, means it will be updated with 9. Okay, so this is what we need to do. Now again what we have, we need to, at each step we need to find the current end, and the farthest we will be calculating while moving through this max reach array. And what we'll do, we need to, means these tabs will denote the same thing. So everything else remains the same, just the means the logic of code, everything else remains the same, just we means avoided the sorting logic by creating this temporary max reach array, because in each step we needed to find out the left, means the rightmost left that we had, which covered the means of farthest range or right. So what if this thing was already pre-computed, means if we are already given an L, we already know like what will be the maximum right that we can cover. So this is what we did. Now what we'll do, we will move in this max reach from, like initially we are moving current end less than n, means we are moving from 0 till n, so we are moving till just this point, because obviously there will be a tab at this step which will cover this, means at least this point itself, right? So we are moving current until this. So what we need to do, will not move till max reach of n, because we know like the max reach of n will definitely cover this n itself. So we need to cover the range till n minus 1 and n. So we need to cover this range, means water this range. Okay, this is what makes this problem hard. We do not need to account the points, we need to cover the ranges. The definition here is different. Okay, so we'll be moving max reach the same way we moved current end in the sorting solution. So what we'll do, at each step we'll be updating our farthest that we can reach with the farthest comma max reach of I. Means if we start at the ith index only, if we start at ith tab, what will be the maximum that we'll be able to reach? This farthest will be storing. Now if at some step it has become that we have, means this I is denoting the current end, means I is equals to current end. That means we have covered till just before I. Okay, current end means current end equals to I, means we have watered just before till I. So if I has become current end, then that means that a new tap needs to start from here. Okay, from this point. And if this means that if the farthest that we have calculated at I is till I only, then that means for I plus 1 we will not be able to cover this range. Okay, so if at any point this current I has reached the current end and the farthest that we can go is less than equals to I only, then in the next iteration for I plus 1 we will not be able to cover this range, because obviously for this L we will be having the R on right only. Okay, so in this case if farthest is less than equals to I, we will simply return minus 1, or else we will be simply updating our current end with the farthest that we will be getting here, and we will be increasing the tabs count, because we need to now utilize some tab, because I has reached the current end. So we need to utilize a tab which has the left point at this point. Okay, so this is how what the approach will be using, and in the end we also need to check that the current hand has reached n or not. If it has not, then we need to return minus 1, even if we have already exhausted the max reach array. Okay, and then simply return the number of tabs required. So this will be the means the big of n approach, big of n space, as well as big of n time complexity approach. Both are big of n here. And initially it was big of n log n and big of means constant space. Constant space if we avoid the sorting space that we require internally. So this is like the most optimal approach for this problem, and if it is like asked in interviews, it will be like real tough to get into the solution, because this is like very greedy, and like thinking about greedily in like time pressure may be very difficult. So you like need to practice similar problems of like interval coverage to solve these kind of problems. You should be aware, like first thing, like whether we need to sort it on the basis of start points or end points. We have like multiple problems related to that, and if we already know like on what feature we'll be sorting, then we need to utilize it effectively. And then in this problem we observe that whether sorting is necessary or not. So we tried to see what sorting was doing here, what means advantage sorting had, and what can we means utilize it without sorting. So we knew like what if we already calculated the max age, then we do not need to sort it. And this is what we did, and the means initially it beat 7%. Let's try to submit the new code here and see how well it performs, because now it is of the order of n only. And as you can see, it runs in 0ms and beats 100% of the solutions. That means this is the most optimal approach for the solution. So I hope you got all the approaches, how we transitioned from like the sorting to the non-sorting part, and how we'll be solving these interval coverage problems on the basis of like either sorting the intervals or keeping track of the maximum range that we can cover till a particular point. And if you have yet any doubts remaining, feel free to comment down and I will be happy to help. Thank you so much for watching.